Welcome back. This notebook provides an overview of Python syntax. In addition, we'll look at basic data types in Python. In learning a new programming language, we can save ourselves a lot of headache by first learning the underlying assumptions that a language makes about data storage. In this short video, we're going to peel back the curtain on Python data storage and look at Python's dynamic typing system. By the way, this notebook is on my GitHub, and I also have a link here for official Python 3 documentation. We first look at some basic things to know about Python. Python is an interpreted language. When you run a Python program for the first time, the source code is compiled into bytecode. The bytecode is then executed by the Python interpreter. You can actually see the bytecode stored on your disk. Let's go to Launcher so that we can go to a terminal. I have a Python program already out here, and I'm going to run it with an argument here of my name. Now when I do ls again, I see that there's a PyCache directory out there. If I look in the PyCache directory, I see a file ending in .pyc. This is the Python bytecode. If I run the program again and it hasn't been changed, the Python interpreter can just run the bytecode. In Python, we don't have explicit type declarations like int j. Types are checked dynamically during runtime, not compile time. Python's version of dynamic typing is sometimes called duck typing, after the old saying, if it walks like a duck and quacks like a duck, then it must be a duck. So if a variable's type is consistent with what you're trying to do with it, then fine. Otherwise, an exception will be thrown. We'll see an example of this later in the video. Python's syntax is very elegant. Indents are used to identify code blocks instead of curly braces. One statement per line means that you don't need a semicolon at the end of the line. These aspects of the language make it easier to type and read Python. A few other things to keep in mind about Python is that it is case sensitive. Comments begin with a hashtag and can be anywhere on the line. The ultimate style guide is pep8. A Python pep is a Python enhancement proposal. These documents are how the language evolves, originally under the control of Guido van Rossum back when he was benevolent dictator for life, but now by a core group of developers. Another resource I like is the Hitchhiker's Guide to Python. One more thing to keep in mind about Python is that significant changes broke backward compatibility from Python 2 to Python 3, which is why we're only talking about Python 3. One of the things you'll notice the most is the print statement differed in Python 2 versus Python 3. In Python 3, you'll have to have parentheses around the print statement or you get an error. Next, we look at Python variables. Everything in Python is an object, and that means that a variable is just a pointer to an object in memory. Notice in this first block that v at first contained an integer, and later a string with no complaints. What's really going on behind the scenes is that in the first statement, v pointed to a memory location that contained 5, and after this third statement, v is now pointing to a different memory location that contains the string a. Operators for add, subtract, multiply, and divide are what you would expect. We also have shortcut operators such as plus equal. Notice that the plus plus and minus minus operators are not implemented in Python. The plus operator also serves as the concatenation operator for strings. In this block we get a type error because we try to concatenate a string with an integer. We can fix that by using the built-in string function here. In this code block, notice that we put 5 into both A and B, and then we checked their locations. They're identical. However, once we update one of the variables, then they'll be pointing to different locations. Python has basic numeric types such as integer, float, and complex. Booleans are a subtype of integers. Python has many built-in data types or structures such as lists and dictionaries, which we'll talk about in later videos. For now, we'll just talk about one sequence type of data structure, the string. Python doesn't bother with a character data type. A single character is just a string of length 1. Here's another example of console I/O with an extra example about print. Notice you can separate items you want to print with commas, but it will put an extra space in there. The second print just concatenates everything into one long string. We'll look at ways of formatting output later. Let's try some code. Write a few lines of code to input a radius from the user and compute the area of the circle based on that radius. The Python exponent operator is ***, and input will take the user input as a string. You can convert it to integer or float using built-in functions. So pause the video and give this a try. Here's a sample solution. First, we get the radius from the user and convert it to a floating point number. Then we take the radius squared times pi. Notice that we also could have said radius times radius. I commented that line out. Let's see how that runs. Now let's try some more practice. Write a Python program to get two integer values from the user and output the average. So again, pause the video and give that a try. Let's look at a sample solution. So after inputting the numbers, I converted them to integers with the int function, and then added them and divided by 2. Let's see how that works. I'm going to average 5 and 6, and I get 5.5. There is an integer division operator. Let's see how that works. Again, I'll use the same numbers, and we see that it did division with truncation. Let's see what happens if we indent one of the statements at a different level. We get an error. Indents have meaning in Python. We'll look at that in the next video when we talk about control structures. Until then, happy coding!